an overstatement to say no large-scale commercial successes. Some people might disagree with that, but certainly the dominant technology today is snooping cache protocol. And I submit that the reason is that snooping caches work well for a small number of nodes, and directory-based schemes do not. Now, I haven't heard any questions up until now. Maybe it's because I haven't been looking for them. Would anybody like to ask for clarification or challenge anything I've said? I intended this to be an interactive lecture, and I've kind of so far invited any. Please feel free to ask. Okay, so snooping caches have been around a long time as well. They're quicker access. Is there a question? They're quicker to access, at least if the bus is reasonably fast. They actually take advantage of the broadcast capability as I showed you. And something that's very important is that a bus serializes things. And by that I mean that when two memory requests occur, it has to be indisputable that one occurred before the other because both of them go through the same bus. And there has to be some kind of an arbitration to decide which one gets to go first. And so therefore it's always, there's never a tie. You always have, whenever you compare two requests, one occurred before the other. And that turns out to be a very important property because of memory consistency issues. And as I've mentioned before, there are many reasons why snooping caches don't scale. Okay, so buses are out of gas. They become nasty transmission lines. We want to move to point-to-point networks. They can be very fast. Some other observations that we observed, incidentally, these were observations that we made in 2001, but I think they're still pretty much, we're down the path farther, but I think all of them are still correct. Systems have become increasingly hierarchical. So for example, now you see a chip that has 4 processors on it, or 8 processors, some number of processors. The memory system is hierarchical where they may have individual caches and then there's a larger cache below it and there may be another larger cache still off chip or someplace else and they're connected to other chips. So the concept of hierarchy is very, very deeply embedded in our notion of building memory systems, computer systems, memory systems particularly. And we want to capture that. The number of nodes in a system is important, but particularly in the Intel world, a small number of nodes was the place where their bread and butter was, and that was the area that they were most concerned about, and nearly everybody wants a small number of nodes to work well. Another trend that we observed then, and I think it's even more true now, is that when caches were small, you missed all the time just because you didn't have a big enough cache on everything that you wanted to access. As caches have gotten bigger and we've built deeper and deeper hierarchies, it's increasingly become the case that if you miss, and I mean miss all the way down so that you have to go to main memory to get data, it's not because your cache wasn't big enough to hold it in most cases. It's because this is shared data and somebody else modified it and pulling it out of your caching process. Okay, so when you miss, there's a very good chance that actually somebody else has it in their cache. So it's really significant that caches are much faster than main memory. When you miss, rather than go to main memory to get data and wait for this long cycle from main memory, you can get it out of another cache much faster. So we would like to capture data from another cache when possible, rather than having to go to main memory. Okay, as I pointed out already, point-to-point links are fast, robust, they can be indirect. They can broadcast in the sense that you can more or less simultaneously send the same message to all the other nodes, which gets delivered through the network directly or indirectly. And a complete interconnect may not scale, but this scheme doesn't necessarily depend on having every node connected to every other one. You'd like to have that, but when you get large numbers of nodes, obviously you can't because the number of links required grows as n squared. You're going to have everybody communicate with everybody else directly. So the basic idea that we started with was, well, we want to do something like snooping. We're going to do it by broadcasting on all of the links.